Solving equations by flowchart is something that might help you later on when you're solving equations by balance, because it really just breaks down the whole idea of performing the reverse operation to each part of your algebraic expression. Now, you probably won't use it for long because it only really works well when you've got an algebraic expression on one side of your equation and a number sitting on the other. As soon as you've got one that's more complicated than that, this isn't a great method. But it is a good method for just understanding the whole idea of balance. So the first step is you build an algebraic expression out of this. So you say, all right, how did they get 3x plus 1? Let's start with the x and consider what's happened. It's almost like we've dressed it up. And later we're going to strip that disguise off so that we can see what x equals. So if we take this x, how do we build 3x plus 1 out of it? Well, the first thing that must have happened is x must have been multiplied by 3 to turn it into 3x. So you start with an x, and for each operation you put an arrow, and you can write what the operation was on top of the arrow. If you take x and you times it by 3, you get 3x. And if you take 3x and you add 1 to it, that's the operation, add 1, then you get 3x plus 1. So that's the whole left-hand side of the equation there kind of built. We've really built it and broken down the steps. All right, we've been told that 3x plus 1 is equal to 7. So the next thing you do, you line up the 3x plus 1 and the 7, because apparently they're equal. We're told that. Now we make our arrows go back the other way, and we want to perform the reverse operations. So what's the opposite of adding 1? Subtracting 1. And what's the opposite of multiplying by 3? Dividing by 3. Now we can go ahead and perform these operations to the 7 and see what's level with the x, because that's what x is going to be equal. So see how conceptually here we've sort of dressed up the x with two disguises. We're going to strip off those two disguises to see what it equals when it's not in disguise. So 7 minus 1 is 6, and 6 divided by 3 is 2. Now that one would have been an easy one to do just by spotting the answer. We can see that 3 2s is 6, and you add that 1 to that and you get 7. But this method could be used for algebraic expressions that look quite simple, even when the answer to the equation doesn't come out quite so nice. So for example, if we had here 3x plus 1 is equal to 8, that would now be a little bit harder to spot the answer, wouldn't it? It's going to have fractions in it. Straight away it looks a little bit harder to do by inspection. But by flowchart it's quite easy, especially if you can use a calculator. So we've got 3x plus 1 is equal to 8 this time. Well, 8 minus 1 I can easily do in my head. That's 7. And 7 divided by 3, well, you don't really need a calculator to do this. The easiest way is to take your 7 and just divide it by 3 like that. And we use fractions in equations all the time when we get to the answer stage, because often the last thing that we have to do is a division. And you can do division by just drawing a fraction line, that means divided by, and putting what you're dividing by on the bottom. So in this case, if 3x plus 1 is 8, x has to be 7/3, which is the same thing as 2 1/3. But you can leave your answer like that, and it's quite straightforward and easy to do. So this method definitely gives you the chance to solve slightly trickier ones than you could by inspection.